Hi everyone, this video is on the mixed exercise 13, question 13. So we have this diagram, and this curve has equation y is equal to x cubed minus 6x squared plus 9x. And in part A, we want to show that the equation of the curve may be written as y is equal to x times x minus 3 squared. So basically, we want to factorize the equation of the curve. So one way to show this is by looking at the graph or even just guessing, because if we substitute x is equal to 0, so we can pretend that we are guessing that one of the solutions is x is equal to 0. So when x is equal to 0, y is equal to 0 minus 6 times 0 plus 9 times 0, which is just 0, right? So essentially x is equal to 0 is therefore one of the solutions, even though we're given the graph and we can just see that without any need of substitution. But yeah, let's pretend that in the exam you're not given the curve maybe. Um, okay, so one of the solutions is x is equal to 0, and we can use our usual technique that when we guess the first solution and then we use long division and divide the entire equation by the basically by x minus the root, and that gives us an expression that can be factorized to find the other solutions. So in this case, since the solution is x minus 0, which is essentially just x, we don't need to use the proper long division. We just need to just do a simple division like x cubed minus 6 squared plus 9x divided by x, rather than setting up the long division, because again, the long division is always the entire equation is divided by x minus the root. In this case, the root is 0, which doesn't make any difference. So that's why we are not using the long division, because there's no point in doing that. So now we get x squared minus 6x plus 9. And now if we factorize this expression, then we'll get the remaining roots. So x squared minus 6x plus 9 is obviously equal to x minus 3 squared, right? And as you can see, we have basically factorized x cubed minus 6 squared plus 9x to basically one of the solutions was just x, and then the other part is just x minus 3 squared. I mean, just looking at here, so x times x minus 3 squared. And therefore, we have shown that this can be written as this one. And hence, we want to write down the coordinates of A. So A has simply coordinates 3, 0. So as you can see, this part gives us the coordinates, the x coordinate of A. Right, for part B, we want to find the coordinates of B. So the point B is an interesting one, because B is a maximum in this curve, and we want to find the coordinates of B, so we simply need to use differentiation. So we first differentiate x cubed minus 6x squared plus 9x, basically the equation of the curve, and then we set that equal to 0 and find the x coordinate, and we can always check at the end that if that's the maximum. So in this case, we have divided by dx, which is equal to 3x squared minus 12x plus 9, and now we set this quadratic equal to 0, which is essentially 3x squared minus 12x plus 9 is equal to 0, and we can divide everything by 3, so we get x cubed minus 4x plus 3 is equal to 0, and this is equal to x minus 1 times x minus 3 is equal to 0. So there are two solutions, x is equal to 1, x is equal to 3. However, when you look at the curve, x is equal to 3 is actually point A, which is a minimum, but point B is here, is before A. So definitely the x coordinate of B is definitely equal to 1. And we can also go and check if that's indeed a maximum by just doing the second derivative test, just in case. So the second derivative test gives us 6x minus 12, and then when we substitute 1 here, so when x is equal to 1, then squared y by dx squared is 6 minus 12, which is less than 0. So indeed, that's a maximum. Anyway, so point B has x coordinate 1 and then y coordinate, just when we substitute 1 into the equation of y, then we'll get 4. So this is the coordinate. We have the coordinates of B. Right, and finally part C, we want to find a area of the shaded region which is bounded by the curve and the x-axis. So it's just a simple integration between 0 to 3, because those are the limits, and we just simply integrate the curve because we want to find the area bounded by the curve and the x-axis. So we just have the integral of x cubed minus 6 squared plus 9x dx. So x cubed integrates to 1 over 4x to the power of 4, 6x squared integrates to, it's obviously minus, so we have minus 2x cubed, and then 9 over 2x squared between 3, 0, and yeah, so when we substitute, we get the value 15 over 4 for the area. And yeah, so that's basically the area of regional.